Hey you guys, welcome back. Today we're going to go over the Unit 2A study guide. This test is going to cover expressions and equations. So let's go ahead and get into it, okay? Question number 1 says, please simplify each of the following expressions. So looking at these, whenever we simplify an expression, we're talking about two different methods. We're talking about the distributive property, number 1, and then we're talking about, abbreviate right there, combining like terms. Those are the two methods we have for simplifying an expression. All right, so let's look at the first one. 4x minus 7 plus 8x minus 2. Now, whenever I see these things, I always rewrite it, and I'm going to rewrite it because I want you to be able to see it, okay? But essentially, whenever I rewrite it, I always change any subtraction to addition and the sign of the following number. So let's change this one, subtraction to addition, that becomes a negative. Subtraction to addition, that becomes a negative. So now let's go and combine like terms. It's so much easier when we're combining when we're dealing with all addition, okay? So let's see. Any like term is a term with the same variable raised to the same power. So let's see, 4x. Is there any other term with just an x in it? Yeah, there is, 8x. So whenever we combine like terms, all we're doing is adding the coefficients. So 4 plus 8, that gives me 12. And I'll keep the x exactly as it was. So I'm done with those, I'll mark them out. Now I have negative 7 and negative 2. I changed those signs earlier so that I can change this into an addition problem, okay? Because that's a lot simpler to combine like terms that way. Negative 7 plus negative 2, that gives me negative 9, so plus negative 9. Or the simplest way to write it would be this, 12x minus 9. But these are the same exact thing because subtracting a number is the same as adding the opposite number, all right? So either way you wrote it would be just fine, okay? We'll count both. All right, I'm going to put it here because that's the way you're probably most likely going to see it. Okay, let's look at this one. Now this is going to be an example of the distributive property. I have this 4 on the outside. I'm going to distribute it into everything inside the parentheses. Whenever we distribute, we're talking about multiplication. So I have 4 times negative 5x. All I do is multiply the numbers. 4 times negative 5. That gives me negative 20. And then there's an x over here, so I just keep it the exact same. Negative 20x. Then I have this plus sign, I'll keep it. 4 times 2, that gives me 8, so negative 20x plus 8. Let's look at the next one. Now this is an example that involves both the distributive property and combining like terms. Whenever there's a problem, an expression that combines both of those methods, we always have to do one before the other, and the one we have to do first, no matter what, is this one right here. We always use the distributive property first. That is a 1. And then combining like terms second, all right? That's because if I went and tried to combine this 8y and 4y, I mean, this is in parentheses over here. I know how to take care of the parentheses first, according to PEMDAS, right, the order of operations. So I can't even combine like terms if I wanted to. Where would I even put the number? I would still have these parentheses to deal with, so that doesn't work, all right? We can't combine like terms first. We have to use the distributive property first. So I'll use that first. Distribute the negative 3 to everything inside the parentheses. Now, I always like to change these subtraction signs to addition and the sign of the following number whenever I see things like this. So negative 3 times 4y, that gives me negative 12y. Just multiply the numbers and keep the y. Plus, and then I have negative 3 times negative 3, that gives me positive 9. Then I'll just bring everything else down at the end of that equation because I haven't used it yet. So now I'm going to go through and combine like terms. Negative 12y, I'm looking for any other term with a y in it, all right? But with a y in the same variable. So let's see, 8y, yep, that's a like term. When I combine like terms, all I'm doing is adding the coefficients. Negative 12 plus positive 8, that gives me negative 4, and I'll keep the y the same. Done with that one, done with that one. So now I have 9 minus 5. Or if you wanted to, that could be 9 plus negative 5. Same thing either way, whatever you're more comfortable with. 9 plus negative 5, that gives me positive 4. So that's how I combine like terms and use the distributive property in the same expression. All right, let's look at the next one. 7x squared plus 3y minus 2x plus 9y. So whenever we're looking through a problem like this, there's no distributive property because there's no parentheses anywhere. So instead, I'm just going to go and combine like terms. I always like to change those subtraction signs to addition and the sign of the following number. All right. So now let's go and find like terms. 7x squared. That is not a like term with negative 2x over here. They have the same x, but look, this one has a variable. This one doesn't. It actually has a variable of 1. Remember, we don't have to write it has an exponent of 1. We don't have to write that exponent if it's just a 1. All right, so these are not like terms because the exponent's different. So I'm going to keep 7x squared because it actually has no like terms. Look, there's no like terms with it. I'll mark it out because I'm done with it. Let's see, negative 2x, it doesn't have any like terms either. There's no other term with just an x in it. So I'm going to keep that the same, plus negative 2x. That's weird, that's a negative 2. Done with that one. 3y plus 9y, those are like terms because they both have a y in them. I'm going to add the coefficients to combine them. 3y plus 9y, that gives me 12y. Now, this is just fine if you wrote it like this, but you might also write it like this, 7x squared minus 8x, because we don't usually leave plus and negative whenever we're simplifying. That's why you won't see it in a problem. You would just see the minus, all right? But these are the same thing, and whatever you wrote, I would definitely count. Plus 12y, that's our simplified expression right there. Let's look at the next one. Please evaluate the following expressions. So when I'm looking at this, it says 3b minus 5b plus 4. Every time I see a b, because it says b is equal to negative 3, every time I see a b, I'm going to substitute a negative 3 in for that b, okay? So let's go and write this, 3b, but instead of a b, I'm going to write negative 3. And remember, this is multiplication. Whenever I have a coefficient and a variable, they're being multiplied together. So I'm going to separate it with parentheses to keep that multiplication at the top of my mind, okay? Minus 5, instead of a b, I'm going to write negative 3, plus 4. So now I'm going to go and use the order of operations, PEMDAS, as we so familiarly are familiar with, we'll call it. PEMDAS, the order of operations, 3 times negative 3, that gives me negative 9. 5 times negative 3, that gives me negative 15, plus 4. I'll bring down this minus sign that I had up there before. And again, normally I like to go and change these to addition and the sign of the following number. I kind of forgot on that one. That's okay. I'll just bring this subtraction sign down. Now, a minus and a negative, when those are right together, I always change subtraction to addition and the sign of the following number. So this is really plus positive 15 plus positive 15. Either way you did it, I'm going to rewrite it just to make it a little easier to see. And now this is my new expression. So let's go and combine those like terms. Negative 9 and 15, that combines to give me 6 plus 4. Now 6 plus 4, that combines to give me 10. And that's what I'm left with. We kind of end up with this upside down triangle shape, right? Kind of like an upside down Dorito, you know? So I end up with 10. Now I'm going to give that a bit of an erase, and let me show you one other thing that you could have done here, okay? Some of you have already caught on to this, and it's amazing. We have talked about it, but it's easy to forget. So whenever you see this, this is an expression. Whenever we see expressions, we can always simplify them, and we always should. If we're able to, we always should simplify. Just like we did up here, we always simplify by using the distributive property or combining like terms. In this one, there's no distributive property, but there are like terms I can combine. 3b and 5b, those are like terms because they both have the same variable. Change that to addition and the sign of the following numbers. Let me go combine these. 3b plus negative 5b, that gives me negative 2b plus 4. And now, let me go and add that negative 3 in for b. I'll go substitute it. So negative 2, I'll add that negative 3 in, plus 4. Now this gives me, let's see, negative 2 times negative 3, that's 6, plus 4, that gives me 10. Notice how much easier that is when you simplify the expression before you start evaluating, all right? You have fewer steps to do. Regardless, you get the same answer, so whatever you do or whatever you feel more comfortable with is just fine, but this is way simpler, all right? That's why we learn how to simplify expressions, to make this work a little simpler for you. Let's look at the next one. Negative 7x plus 2y. X is negative 2, y is 4, so I'm going to go and substitute those numbers in every time I see their variable. So negative 7, x is negative 2, I'll go substitute x for negative 2. Plus 2, y is 4, I'll go substitute a 4 for y. And now I'll go and do the order of operations. I'm not going to go and add first because that comes later. Look, I got to go and take care of it in this order. So I'm going to do multiplication first. Negative 7 times negative 2, that gives me positive 14. 2 times 4, that gives me 8. So now I have 14 plus 8. And that just gives me 22. And that's my final answer then. Let's look at the next one. negative 2c plus 4c minus 3. Now this is the same problem as letter A over here. I could go and substitute every c with a negative 5, but to make it a little simpler, I'm going to go and combine like terms first. Negative 2c plus 4c, that just gives me positive 2c. So I just combined negative 2 and 4. That gives me positive 2. Minus 3, I'll bring down the rest of that expression. So now I'll go and substitute c for negative 5. So 2 times negative 5 minus 3. 2 times negative 5 is negative 10. Minus 3. Now I could go and change subtraction to addition and the sign of the following number. So now this is negative 10 plus negative 3. That gives me negative 13. All right, I'm going to give this a little bit of an erase. That way I can scroll down. There we go. Let me scroll down just a little bit. Let's go to the next set of problems. Let's look at these. Now this one says, please factor these expressions. Whenever we factor, it's one of those few things in math that's actually named really appropriately. Whenever we're talking about factoring, it's basically the distributive property backwards. So I'm trying to pull a factor out of this expression. And the factor that I'm going to use is, of course, the greatest common factor, the one we all know and love, the GCF. So let's go and find the greatest common factor of this expression. Right now I have negative 15 and 35. I'm going to go find the greatest common factor of 15 and 35. Now I'm going to write them out on this problem just so we can get a refresher of what factors are. But normally I'm probably not going to write them all out. I'm going to think, what would be the greatest common factor there? Okay, so for this first one, let's write them out. Factors of 15 are 1. Every set of factors starts with 1. 1 and 15. And then 3 and 5. Notice how I do them in pairs. That way I don't forget. Okay, I don't want to forget any. Factors of 35, that'd be, let's see, 1 and 35. 5 and 7. Is that it? I think that's it. Yeah. Looks like the greatest common factor was a 5 right here. So the way I'm going to do this is I'm going to pull that greatest common factor out. So I'm going to pull that 5 out. And that's going to be the outside of my parentheses. And then I'm going to go and divide both of these factors by that GCF of 5. Negative 15y divided by 5, that gives me negative 3y. 35 divided by 5, that gives me 7. And I had a plus in the original. I'm going to keep it right there. So now I have 5, negative 3y plus 7. I can always check my work with these because I could actually use the distributive property and make sure I get the same expression I started with. 5 times negative 3y, that gives me negative 15y. Good, I have that. 5 times 7, that gives me 35. And that plus sign in the middle. Perfect, I know I did it right. Let's look at the next one. 8x and 18. So I have to find the greatest common factor. When I'm thinking about numbers that go into 8 and 18, let's see, 1 and 2, they both do. 4, that goes into 8, but not 18. 6, nope, that doesn't go into 8. 8, does 8 go into 18? No. So you know what? It looks like the greatest common factor here is just 2. That's the only number that goes into both of them. So I'm going to pull that greatest common factor out, and it's going to go on the outside of my parentheses. Then I'm going to divide both of these terms by that GCF. So 8x divided by 2, that gives me 4x. I just divide the numbers and keep the variable. 18 divided by 2, that gives me 9. And then that's a positive 9, and I'll keep that plus sign. Perfect. Now let me go check and make sure I did it right. 2 times 4x, that gives me 8x. Perfect. 2 times 9, that gives me 18. Plus 18. That's perfect. I did it correctly. That's great. Let's look at the next one. Negative 33c plus 55. Now this is one of those things where you got to really try and think, what goes into 33 and 55? This is where knowing your multiplication facts makes this so much simpler and quicker for you. Let's see. If I think about the greatest common factor, it'd be 11. 11 goes into both of those. Yeah, let me pull an 11 out of there. So that'll go on the outside of my parentheses because the GCF is 11. Then we can go and divide both of these terms by the GCF of 11. Negative 33c divided by 11 gives me negative 3c. 55 divided by 11, that gives me 5. I could double check and make sure I did it correctly by using the distributive property. 11 times negative 3c gives me negative 33c. 11 times 5 gives me 55. Yep, that's perfect. Did it right. All right, that's going to be part 1. I will see you guys in part 2.